Okay, let's look at a few more examples of this uh, of functions of this form, and we begin with some function f of x, and we're looking at what happens when we do f of x plus h minus f of x divided by h. Okay, so we're looking at this. Now the example that I want to look at now is when f of x is equal to x to the fourth power. Okay, so that means that this is going to look like as follows. F of x plus h will look like x plus h to the fourth power minus x to the fourth power divided by h. So let's look at what happens here for a couple of values of h. In particular, let's say I look at h equal 1, maybe h equal to 0.01. Okay, with that now, here is our function. Right up in this corner, we have y is equal to x plus 1 to the fourth minus x to the fourth divided by 1. So that's our x plus f of x plus h minus f of x divided by h. And here is what the graph of the function looks like. Okay? Now suppose instead of using 1 up here in this expression, I use 0.01. So I have this expression right here. Notice how this curve changes, how it appears right here to pass through the origin. So we've moved from this curve up here to this curve down here. From here to here as h goes from 1 to 0.01. At this point, I'd ask you to see if you can't estimate what this curve is. Give me an estimate for what that curve is. Now let's look at another example. Okay, in this one I want to take use a function that we learned in geometry. Okay, I want to look at the sine f of x equal to the sine of x. So f of x equal to sine of x. So in this case, f of x plus h looks like sine of x plus h minus sine of x minus f of x is the sine of x divided by h. Okay, so I'll look at this expression. I'm going to evaluate this expression for h equal to 1 and h equal to 0.01 and see what we get when we do that. So let's go back here. Here's our plot. Okay, now here's our first equation right here. Okay, this is sine of x plus 1 minus sine of x divided by 1. So that's f of x plus 1 minus f of x divided by 1. So notice this expression. It kind of doesn't look all that different than the value of the sine. Now what happens if we move from x plus 1 to x plus 0.01? So sine of x plus 0.01 minus sine of x divided by 0.01. And that looks like this expression right here. Look at that. So it moves from here to here. Now I want you to look at this. Suppose I also plot here on the same graph, I plot y equal cosine x. I plot y equal cosine x. Here's y equal cosine x. There. Plot it in black. Y equal cosine x. It exactly overlays this expression. So here's this expression. Here's y equal cosine x. Okay. This expression, y equals cosine x. They're virtually indistinguishable from one another. Wow, that's pretty interesting. Try it yourself. This is something I want you to do, okay? And where I went from x plus 1 to x plus 0.01, try putting in some other values and see if you can get some idea how the graph goes from here up to here. Okay? Okay. See you next time.